write a function whose graph is the graph of y equals x cubed. That's your basic. But is shifted to the left 4 units. Well, that means if it's left, h is what? -4, right? And if I'm on the inside, I'm looking at a function of the form something cubed, right? This would be x minus h cubed. Right. So this then becomes that f of x would be x minus h is minus 4 cubed, or is going to be x plus 4 cubed. Well, on the inside, it is the reverse of what you think it is. Shifted down 4 units. Now we're not in the h world, we're in the k world. And in this case, k is what? -4. So that means I'm now looking at f of x equaling x cubed plus k, right? Because I'm on the outside. Or, in this case, f of x is equal to x cubed, k is a minus 4. Now, what you want to think about as you approach this next test, these are the kinds of problems that can be done rather quickly, right? What's going to be a pain in the rear? The graphs. What you want to go through, and you want to go through and rather rapidly hit the ones that can be done really quickly, that you feel that can be done very quickly. But these are one of these kinds of things where it really can be done pretty quickly if you are familiar with your transformations. Horizontally stretch by a factor of 4. That says that if it's a horizontal, it's not c, what is it? It's 1 over c. And in this case, a factor of 4 would be 1 over 4. So that says that this would be f of x equaling, remember this is c times x, that's your basic, and that would be cubed. Or f of x would be not c, 1 over c, well, yeah, it is c, would be 1/4 x, the quantity cubed. Because the multiplier is not c, it's 1 over c. So what's multiplying is c, so that means I have to flip the 1/4. That's the hardest of the transformations. Find a function that is finally graphed after the following transformation. Remember, I have you list the transformation? This is the listing of the transformation. Your basic function is square root of x. Reflect around the x-axis. What happened? I have to have a minus sign. Minus reflects. If it's the x-axis, is the minus inside or outside? Outside. So this would be minus the square root of x. Right 3 units. Left, right's on the inside, right? And it's x, it's either going to be plus or minus 3. In this case, it's going to be a minus 3 because I want a plus 3. Because it's always x minus. And then down 2 units, this would be x minus 3. Down is on the outside. So there's your function that matches that listing. He's to the right 3, flipped upside down, and down 2. He matches the list. Cool. Cool beans. Shifted up 2 units. Well, that says I've got the square root of x, and if he shifted up 2 units, it's plus 2. Reflect around the y-axis. Where's the minus sign? Y-axis. Y-axis. Who's changing sign? Who's changing the sign? X. See, if it's around the x-axis, who's changing sign? Y. So that means that's on the outside. Here it's on the inside. It's going to be minus x plus 2. And then left 3 units. This is scary. I'm going to put the minus there. And if it's left, this would be x what?
Plus 3.
Well, if minus x minus 3. So you could do a minus, but the x has to be minus. This is left, reflect, up. If you want a minus, it's going to have to be a minus 3. Then that becomes a minus 3. And then, no, it wouldn't, because what would bring this back to 0? If I put a plus 3 here, minus 3 would be minus 6. But if I put a minus 3 there, minus a minus 3 plus 3 is 0. This still leaves it as a left 3. Because x has to be minus 3 to bring it back, which is why I wrote it the way I did. More